Hi, everyone, and welcome back to another session of Shifting Gears with SDV. I'm your host, Ludmila Muiña, and I'm excited to welcome our guest speakers today, Agustín Benito Bethencourt and Luis Cañas Díaz, who will be presenting lessons learned in our BI journey from open source to software-defined product development. If you have any questions during the session, please feel free to drop them in the Ask a Question tab or directly in the chat. And with that, over to you, Agustín and Luis. Thank you so much.
Thank you, Ludmila. So thank you, everyone. Well, first, thank you for giving us the opportunity to talk here. It is super, we are super happy to be here. So thank you. As you know, lately is easier than always to get videos and content. We think that the added value of this talk is that you have the opportunity to talk to us. So in case you want to drop some questions, if you want to interrupt, please do it. If not, please share some questions through the chat. And as we are two people, the one that is not talking will try to answer. So as Ludmila said, we're going to talk about the lessons learned from our business intelligence journey. And what we learned analyzing open source projects and in the automotive industry. So let's go. So let's skip the table of contents. So please, Agustín, introduce yourself so we can start.
So my name is Agustín Benito Bethencourt. I work as an independent consultant in the crossroads between open source and business, and I've been focusing in automotive for some time, and I still do part of my time, and I'm glad to be back at Eclipse Foundation activities. That's it. Go ahead, Luis.
Thank you. My name is Luis Cañas Díaz. I've been working in analyzing open source projects for the last 15 years, kind of. So I'm an open source enthusiast, and I'm also a co-founder of a company called Bitergia. And working for Bitergia, I had the opportunity to work with Agustín in analyzing the software delivery process in the automotive industry. So this is why we are talking here. So business intelligence. We know that business intelligence is an approach used in many different areas of the industry, and we believe that it should be also used in software. Why not? So we know that the production of software is super complex in the automotive industry. And so with all the pressure, with all the hierarchy, T1, T2 suppliers, this is getting more and more complex. So what we are trying to do here is to extend other frameworks that are used to help you in the software delivery process. Those frameworks typically use surveys, and our approach is bringing data. So we think that bringing data, we will be able to go deeper. So that's our goal, and this is like the map of our journey, and I'll use this as a reference for the first part of the talk. In the BI journey, the goal is to transform data into insights. So we go from data to information to insights, and we split the journey in 5 different stages. The first 3 ones, stage 1, 2, and 3, are very focused on analyzing the information that we obtain up to date, and the next 2 are oriented to predict what is going to happen. So, for instance, in the stage 1, we are going to focus on collecting all the data from different sources, from different tools, in order to be able to have all the data points that we are able to collect. The goal is that we can provide all those data points to the stage 2, where we describe the process in what we call descriptive analytics. And the goal here is to describe the system, the software production system, following an end-to-end approach. End-to-end is something that you will hear a lot during this talk, because we think it is key to get this end-to-end description of the system before we go forward. And in the stage 3, we go forward, and based on the description that we obtain in the stage 2, we go into the symptoms, the most relevant symptoms, and provide some recommendations. So after these 3 stages are completed and we have a view of the system and the main symptoms, we can enter into the fourth stage, which is the predictive analytics. But for that, it is key to have all the model created, all the data, in order to be able to apply technology like machine learning in order to predict what is going to happen. The last stage of this journey is to provide some prescriptions, some recommendations, so the organization is able, all the project, if we are talking about open source projects, are able to provide, are able to improve the software delivery process. So to sum this up, we want to promote data-supported decision-making processes, and we want to promote a continuous improvement processes. This is key, okay? And this is also key for applying machine learning and AI. Having good data sets, having a good description of the production system is key to apply ML and AI. So our recommendation is to do it this way, not starting with AI first. So let me describe now the first 3 stages I mentioned in the diagram. The first one is data. The goal here is to get all the raw data from the different tools that we have available and to transform it into information, into data that we can consume. And in order to do this, the data collection must return high quality data. Without high quality data, the next stages are going to suffer. The description is going to be poor, and the analysis of the symptoms, the root causes, and the remedies is going to be even poorer. And if we are talking about machine learning, then if you are familiar with machine learning, you will know that having high quality data is key. But also we need the data collection to be something reproducible, because we need to audit the process. Data is something alive. Data is something that you have to maintain. So you need to basically to be able to trace all the data and where the data items, how they are collected. And last but not least, we have to create a data hub. This is key. This is key because we'll need to provide this data not only to different roles, but also to different tools in the organization. And when we are talking about various sources and various data sources, I'm talking about people. So we need to get knowledge from interviews, surveys, as other frameworks, reports, but also about the documentation. We need to understand the complete process, the complete production of the software from the code is created until it is shipped. We need to understand the whole picture. And of course, we collect also data from tools like source code management systems like Git, Subversion, code reviews like Gerrit, GitHub PRs, integration, testing and deployment from Jenkins, etc. So we, as output of the stage 1, well, the input is that we obtain data from different what we call data sources. The intermediate step is that we have all this data collected with no structure. So we have a data lake. And the output of this stage is that we have processed data. And this processed data, as I said, the goal is that it must be interoperable. It must be something that we can use for different roles and for different tools. So now, once we have the data hub as the output of the first stage, we can start with the descriptive analytics. And here the goal is to describe end-to-end the software production system. And we do this by turning raw data, the data we obtain in the data hub, into information. And we do this by applying different metrics. And in order to classify and to identify the metrics we need, we use 5 different dimensions. So these are the dimensions that we use. We used who, like the actor of the action, what is modified, from a requirement to pull request to build to changing documentation to code. The when is basically when the action was performed. The how is this dimension is related to the process, like the time it took, etc., and the context. So we use this dimension in order to get the metrics that we need to describe the system. And when describing the system, it is key that we focus on using an extensive and horizontal approach. And we have to use it before versus the intensive and vertical approach. And let me use the analogy of a forest ecosystem here. If we want to analyze a forest and we have this drone flying high above, with the drone we can get the landscape, the overall view, and this is what we want at this stage. We don't want to go deeper into the tree and analyze the leaves and the roots and the trunk. We want to analyze the overall forest. And this is what we need to keep in mind, that we want an extensive and horizontal approach. Once this first iteration is complete, we'll have time to go deeper into specific bottlenecks that we identify, and in order to fix them. But first, we need to get this extensive approach view. So we are in the stage 2, and the output of this stage is a data-supported end-to-end view of the software production system. And we do this with simple metrics and dashboards, because we want to describe a complex system with simple metrics. Okay, this is key, because we want to go fast. We want to get, we want to make the maximum impact, and we have to do it this way. And the second output after the description, well, basically reports. The target audience are executing units up to business, and at this point, we may get inconsistencies between the result in the description and what the experts on the ground said. And if that happens, we have to analyze why this is happening. Okay, we'll talk about this later. And it is expected to start having a list of questions that we'll have to deal with later. Now we are starting the stage 3. Remember, stage 1 was about getting data. Stage 2 was about getting the end-to-end view to describe the system. And now we have everything characterized. We can start looking at the symptoms. So the goal of the third stage is to, by using data, is to get to the root causes that are creating those bottlenecks. And at this stage, the goal is to transform the information we obtain from the stage 2 into insights. So remember, we go from data to information, and now we're going to get as an output insights. So there are two things that we have to do. First one is to identify the most relevant bottlenecks, as I said. And for that, we have to identify the ones with the highest impact. And we have to do this by and getting a common understanding about the root causes, with the expert on the ground. And this is key. As I mentioned before, you may have some disagreement with them, and it is key to understand if what we are doing as data experts is wrong, or there is something that we have to discuss. Okay, some of the things that we may face is that there is an error in the analysis, and we have to stop and double check everything to make sure that both the data and the description is correct. Okay, this is something quite important, because we need them. We need them in the same boat. If we don't have it, if we don't have the team in the same boat, this is a lost battle. Okay. And the second thing we have to do is that we have to identify the remedies for these symptoms. And how do we prioritize the symptoms? Well, we categorize them in 3 different categories. First one is that we categorize them by the impact they create in the organization, so organizational performance. Second, by the software delivery performance, and third, by the impact it has in the staff, by the well-being. So as output, the third stage, remember, we started with the stage 1, where we get all the data, and we provide the data to the stage 2, we describe the system. And this stage 3, the output is that the output of this stage, as we propose, is basically 2 reports and workshops, both of them with the main insights from the high for the most important symptoms and the root causes, and some potential remedies that we propose. And my colleague Agustín is going to take the lead now, and he's going to talk about the methodology that we've used in this journey.
Okay, so what we just had was a description of the stages of the BI journey, focusing on the first 3, which are the ones that we that we mostly focused in open source, but also in automotive. What you're seeing now is an example of a process that we follow, in this case, in analyzing an open source project. In this case, the work that we did last year for AGL. So you have there an example of that journey, the process we follow to cover the first 2 stages of the journey. So, yeah. And then the whole idea of this methodology is to be very systematic about our approach, and up to the diagnosis, that's where we usually have some more flexibility depending on the bottlenecks that we end up finding and the remedies that we are proposing. But up to that point, usually we follow the same stages all the time. The first main action that we take is a value stream mapping. This is a very common methodology, so there are a lot of experience out there about how to do this, but it's something that we need to do. And surprisingly, there are organizations that haven't gone through this with all the stakeholders in one room or in one video conference. So there is a lot of value here. I mean, you learn a lot by doing this. Once we understand the process end to end together with the documentation, we move into the tools. And we start to look at what we call the data types, which are the elements that we require in order to understand the system end to end. And you have there some examples of the tools and the data types associated to those tools that we take a look at. So we go from the code management tools, communication tools, release and deployment tools, wikis, and it depends on each organization. We go from different tools. Then once we understand the process, we try to model it. And we start from very simple models, and then we iterate until we get down to the level of detail that we require. What you're seeing there, so we apply system thinking to do the models. These are theoretical models in paper, not AI models at this point. And what you see there is an example of 2 iterations of the model. In this case, we are using also the documentation from the AGL project just because it's open source and we can show it. But for automotive customers, it's exactly the same. The first 2 stages, the first 2 iterations, and then below we apply the information from the value stream mapping with other information we get from interviews and the documentation to actually get a more complex picture of the delivery process. You see there, for example, on the left, you see stakeholders, and then you have the tools and separated in stages, and we sometimes even add significantly more information through tags there. So at the end of the day, it's one visualization that we all understand, the customer or the maintainers and us, so we talk the same language with the same visualizations. And then we get, in parallel, we start to crawl the data and building the data hub. That is something where Luis and his colleagues excel. Us, we use Bitergia Analytics, which is fully based in Grimoire Lab. It's a open source tool hosted at the Linux Foundation. And so, if I have to mention one thing about the tool that is kind of unique, is how it manages identities. When you're dealing with many different tools, one aspect that it goes below the radar and it brings a lot of headaches are how you identify people around all the tools. And this tool has that sorted, and most of others do not. Then we move, once we have the data hub, we move into the metrics. We have different ways of representing the metrics. Luis mentioned earlier the 5 dimensions. You can see a matrix there where we try to cover as much as we can at the beginning. in order to have an end-to-end. So if we find out that we have too many on one area and none on the other one, we try to make sure that we have a good heat map. It's all pretty much in the same color. Obviously, we focus more on certain areas depending on the type of organization, who are the champions of the project. But okay, you see some examples there. And then once we have the metrics with the data, we create what we call the dashboards, that are collections of visualizations and tables and graphs, and that provides a good view of a specific aspect of end-to-end, if as much as we can from the system. So hopefully with 4, 5, 6 dashboards, you get a good overview of your software production system end-to-end. Once we have the descriptive stage done, we move into the diagnostics. And I put there an example of a process of the methodology we follow. In one way or the other, Luis described it earlier. And then once we go into the diagnosis and we identified some root causes, then we move into, okay, now we need to improve, right? And so usually in every company, every automotive company we go to nowadays, they have people that have gone through, that are pretty good at driving continuous improvement katas. So our role there is to bring the data supported point of view. So we do that at scale. And then we play, depending on the knowledge that they have doing that at scale, we play different roles. The end goal is that they can do it on their own very, very soon. And the last thing that I wanted to mention is that in order to link metrics with good practices, there is a whole theory out there related to capabilities, and the relation of capabilities are condensed into a capability model. For those of you interested in this topic, you will probably remember this very famous book from Nicole Fosbury called Accelerate. That is the capability model. That's where the theory that links metrics with good practices was formulated. And there is a capability model there that we have evolved for our own purposes. So then we had some examples, but the last couple of days going through the talk, we realized that we won't have time to get into details here. So we're going to skip it. If we have some time at the end, we will go through them. And we will move directly to the point 5, which is basically the lessons learned. What we will try to describe a little bit are differences and similarities on working in the open, analyzing open source projects, and doing business intelligence in automotive companies, analyzing the software production system. So I think, Luis, you start here, correct?
Yeah, thank you. So let's start with this table we created with some ideas. So imagine in the fourth row, we have data, and there are many differences. There is an obvious difference between working with commercial environments and open source projects. When you analyze an open source project, you have all the data available. So this is not a restriction. Maybe they're using tools that are, they don't use many tools. This is quite limited for open source projects, so they tend to use a fewer number of tools. So some of the tools are not used for what they were originally designed. So the data is always available, but sometimes it is very hard to analyze. But when you enter a commercial environment, it is super hard to access to the data. I've been in this situation working with Bitergia, that we've been working for a company in the automotive industry, and we were there for a couple of months, and we were not able to access the data, so we have to stop and leave. So when we analyze a project in both environments, both in open source project and commercial environment, the minimum execution unit is also different. When you are analyzing open source projects, the minimum is going to be the contributor, which is hard to characterize. But when you are in a commercial environment, you typically tend to analyze teams. You don't go deeper than teams, and teams are kind of easy to characterize. And the same thing happens with capacity. Capacity in companies is something that you can predict. In case there is a change, the change is abrupt. But when you go to an open source project, it is kind of unpredictable. It is true that the growth and the decay is kind of organic, but it is also unpredictable because there is a big amount of volunteer people. And when we talk about metrics, for instance, I would say that the same set of metrics can be applied to both contexts. But when we are working in a commercial environment, we have more different roles that are going to consume the insights. So we are going to need to tweak a little bit the metrics. So the set is a bit higher, but because of the consumer is a bit different. And regarding the organizations, if you are familiar with open source projects, the number of organizations / nonprofits companies in open source projects is huge. When you go to a project that is promoted, that is part of a commercial environment, it is created by a company, the set is quite small. And last but not least, the focus. When you work with a commercial environment, they are heavily focused on improving the delivery performance. And this is different with open source projects. So we have more examples based on what we learned, for instance, about data and tools. We've learned that the data locking is a real risk. So our advice for companies is that when you start looking for new tools for whatever, in the procurement process, evaluate how interoperable are those tools. Those tools are, I mean, because sometimes you will need to take data out of them, and you will need to connect them with other tools. And if this is a pain, then you are going to suffer. Data collection is going to be harder, and then the whole process of BI is going to be harder. So this is why you should take this into account. And second is that you have to focus on creating a data hub. So in case you are you've decided to start this BI path, you have to focus on creating a data hub, because this is key, as you will have many different profiles that will consume the data. We are not talking only about the management. We are talking also about the development teams. And from our experience, we don't need complex visualizations. We don't need complex metrics, at least in the first iterations. Next, if you start with the data collection and you talk to your team, or you are the one collecting data in order to provide the data to a data consultant, make sure that the people doing the job, they know about the context. If not, data collection seems easy until you start doing it. There are many different aspects, many different things that can be stored in different ways, different schemas, or maybe there are other types of information that you thought they will be collected, but they are not. And when you are running the analysis, suddenly you cannot progress anymore. So it is key to provide the context to the data engineers. And as I said before, the data is something alive. In order to do this process and to keep iterating with and to keep doing it while the software evolves, you have to keep updating the data. And the data is going to decay, and you have to maintain the data. Okay, so this is why it is key not only to maintain the data sets, but only to make sure that everything can be tracked from the item that was generated to all the chain that generated of tools that generated this item, in order to isolate the issues generating the data items. It is key to identify the right data types to collect. There are many things that you can collect, from documentation to code changes, etc. This is maybe one of our main highlights from this talk, is that try not to drown into lower impact data graphs visualization. Try to go with the ones that make a big impact in the organization. And last but not least, when you are collecting data, you should be polite with the data platforms that you are mining. So if you start collecting data, pulling data 24/7, someone in your organization is going to hate you. So try to not to make their lives miserable. Next, let's talk a little bit about metrics. I've been talking for metrics for a long time. So, and every time I talk to people, sorry because I don't know your background, but in case you start using metrics and data, if you see yourself in a discussion where you are talking about metrics, if you don't have a common view of the goals and questions that you want to answer with those metrics, stop the conversation. There is a framework we use, an approach, which is called the goal question metric approach. We've used that at Bitergia from the very beginning, and this is also a recommendation from the Chaos community, which is a community project from the Linux Foundation about metrics. With this approach, basically the idea is that first, you organize the ideas in goals. So as soon as you identify the goals of a team organization, you define a set of questions that you need to answer in order to be able to track this goal. And in order to answer the questions, then you have some metrics linked. But you don't start talking about metrics until you have questions and goals, okay? So because there is too much data and too many metrics, basically. And again, as we said before, extensive approach. The idea is that we have, as soon as possible, working skeleton with end-to-end metrics, okay? And we avoid metrics that can be applied only to a specific section, a specific area of your production system. And as we said, implementing simple metrics is going to take you farther than implementing complex metrics. Same ideas with visualizations when you are trying to express the insights to make them more appeal. So first, it is key to identify the meaningful data from all the data that you are going to have available, and you'll have to validate the insights with the people who are going to use them. And you may get requests to add more and more and more, and you have to fight against that, again, with the same idea. A smaller set of insights that are applied to a bigger population, a bigger set of people in the organization is going to make a bigger impact. So this is key. This is key. So using this approach, you are not going to lose the focus, and this is key for the first iterations. So again, extensive versus intensive approach for a bigger impact, fewer outputs to have a bigger impact, and even simple metric that is used end-to-end that shows the end-to-end process is going to add more mean, is going to be more valuable to your organization. Agustín, please go ahead.
Insights, especially in the diagnostic part. Imagine that you end up with a description, and out of that description, you go through a process in which you define some questions, right? Questions that come basically from two sources. Contradictions between the experience that the staff has, that the development teams or the project managers or the executive have when looking at the data, and then anomalies that the data themselves, the visualizations bring. Basically, they come from behaviors of curves or slopes or abrupt changes or data that goes above or below certain thresholds or cycles that are related to, I don't know, organizational events, whatever. You are always looking for anomalies on the data and contradictions between experience and the data. So you have a lot of questions. We have gone through projects in which we attacked several of those questions at the same time, and we end up stopping that. You know, you have, here are some questions that deal with the integrators. Here are some questions that deal with the developers. Here we have some questions more related to project managers or to architects, whatever. So we can split and conquer. Doesn't work very well. So you prioritize them and you attack them one by one. The highest risk is always to put your energy, or the energy of those who are digging into the data and can really bring up, study the symptoms to get to the root causes, the real doctors. End up digging into low impact problems. And then the analysis you do then in iterations. Another big risk, and we'll talk about it later, is to dig too low, too deep. So as you know, you dig a little bit, you end up with partial results, you validate them, and you go again, because in a lot of time there is value in that validation process, and a lot of times you actually can the subject matter expert, the people on the ground, the staff, they can identify the root causes once they have some hints, and you don't have to dig too much, right? So. And then another interesting point that we've learned is that sometimes you have a set of root causes. You have pretty much identified 3 or 4 big issues that that has to go under the spotlight. And but the staff do not agree in 1 or 2 of them or some of them. And you think, okay, we can move on into the next step without them agreeing. It doesn't work very well, because then you go through continuous improvement processes in which they have to invest time, precious time, into providing remedies to problems that they might not feel like they are critical, or at least critical to them. So sometimes you have to make trade-off and go for the second most critical problem just because everyone agrees. And then once you have the trust, you go back to the most critical one. So buy-in it might determine the priority of the remedies you attacked. And then, sometimes insights are very interesting and very valuable. They all are. But some of them are actionable or immediately actionable, and some not. So focus first on the ones that are actionable. That's another one of those lessons learned from doing this several times. Then many times, when you get hired as consultant, or when you start working with an open source project, people is expecting that you bring some knowledge that they do not have already, that you bring something clever that they haven't realized. And it's usually not the case. Usually the signals you are providing are already there. Somebody knows what's going on. It's just that maybe that person is not heard. Maybe that person haven't been able to raise that topic as a priority. Maybe it's not priority 1 for that person, but priority 3. But it's just priority 3 for a lot of people in different areas of the system. So don't underestimate the power of confirming experience. The reality is polyedric, and some people see the same issues, the same bottlenecks, the same symptoms in completely different ways. And then this idea of being humble. If what you're saying contradicts the experience of the people on the ground, you have to double check your data, your visualizations, your dashboards, and ultimately your insights before really arguing with them about the interpretation of that experience. Then the common language part is another of those things that we learn. And we learn this is another one of those topics that we learn in open source, and we brought into commercial environment, and it works really well. Different open source projects call the same thing in different ways. And, so you end up getting so tired of that you end up putting your own language, and that's it. Okay, it doesn't work very well. So if you are communicating to 1,000 people, like for instance in any OEM, or 1,000 or 2,000 engineers or 3,000 engineers, you better adapt to their own language, and that's not always easy. And if you have to choose where to focus on your improvement processes, focus on those root causes, on exploiting the constraints that affect end-to-end. The wider the impact, I think we've said this already 4 or 5 times, the wider the impact, the more value you'll get. And then now we are not gonna be specific. We're gonna touch 3 or 4 different points. The first thing is, in automotive, and you guys know this one as good, if not better than I do. They see open source as an R&D, as playground, as R&D. They don't have this idea that open source are actually really rich and really complex, in some cases, software production environments. And what we are, we like to say that we are a proof of that, because if most of what we bring into commercial environments, we learn it in open source. So analyzing open source projects. So they are outstanding. And the other way around also works. If you want to start something like this, if you want to start putting effort and focus on your production system in order to improve, it's very, very good that you start in the open source projects that you are involved. Start there, learn there, and then bring all that into your organization. Another one of those lessons learned is this is not when we go to OEMs or Tier 1s, this is not a passive kind of executive kind of consulting. We have to get dirty. And that means that, you know, the staff has to be fully involved and cooperate and put time. We have struggled with this sometimes. And it's very hard because it takes us a very, very long time to understand how the production system of the organization works if they don't help us to do that. So yeah, this is one of the things that is very important. And the value matters, transparency matters, no vendor locking matters, all those variables, all those principles that we apply in open source, they are extremely valuable when you are doing a service that touches so many people, that touches so many sensitive areas, and that might have such a big impact within the company. And then finally, yeah, the AI, right? We all suffer from, I don't know if say that I'm halfway excited and halfway tired of the AI topic. The first thing we get is, what are you doing with AI? Why are you not applying AI? And you know, we say the same thing. It's like, how are we going to apply models to your software production environment if we don't understand how it behaves? If you don't understand how it behaves. So you cannot create models if you don't understand the behavior of a system. And you cannot understand the behavior of a system if you are not able to even describe it end to end. And you cannot describe it end to end only based on experiences from people or surveys. In our view, you need to go down to the data. Then we can argue if you need more data, less data, but you need to do your homework. So what we are saying is, okay, this is the kind of thing that is the homework. So in 1 year, in 2 years, or in parallel, you bring, you know, people that are experts in modeling stuff and doing machine learning, and maybe you will get to a point in which you will be able to apply some AI models to predict the behavior of your system in certain circumstances. Do not lose focus. You know, these are complex projects. You touch a lot of data from a lot of tools managed by a lot of people. You are dealing with activities, everyday activities for a lot of engineers. Losing focus is very, very important. So we mentioned before that what we want is to bring data to decision-making processes and to continuous improvement. But we cannot forget what is the other part. What do the other part wants? In commercial environments, what they want basically is to reduce time to market, but they need to balance the quality, introduce innovation rates, and hopefully, I think automotive still suffer a lot from this. They don't take into account enough well-being of the staff. So they need to balance that, right? And that's the ultimate goal. It's very, very easy to lose focus on that. And why am I saying this about the focus, which seems to be obvious? Because as soon as we get into a customer in automotive, we start to get pulled in a whole bunch of different directions. So it's quite hard to keep the focus, and 95% of our effort on that focus. The first thing we noticed, we were discussing which bullet points to put in this one. And the first one is accuracy. I mean, the discussions about being accurate, if you think about the ultimate goal is bring data into decision-making processes and into continuous improvement processes. You don't need accuracy for that. I mean, accuracy is welcome, but it cannot be at the expense of simplicity or end-to-end. You know, this engineering culture in which you need to be constantly accurate and precise. It's not the goal. Maybe in 3 or 4 years down the road, when you actually are very mature in this journey, then, but not now. Then a lot of people call us or try to bring data to confirm their theories, and that's it. It's all they are interested on, and they are not humble enough, in our opinion. And then, one sickness that the automotive industry has, in our view, is creating these dashboard as a service teams. They call them data engineering teams or all kind of names, but in fact, what we've seen is that they are basically dashboard as a service teams, and we haven't seen them working very well. A lot of effort and a lot of goodwill put into a bad setup that are basically failures. So the last one, this is a pretty important one, right? What we do is we analyze the software production system. And in order to do that, we look at the environment, all the elements that interact with the system. Obviously, one of the core elements is the people that are interacting with the system. We call them minimum execution units, to use the same terminology for open source and for commercial environments. In commercial environment, those are teams. One of the good things we do in open source is, in general, being very sensitive to people. That's not the case, sadly, in automotive, in many commercial environments, in many automotive companies. So when you are measuring the system and the interaction with the system, you are not measuring the execution unit's performance. You're measuring the performance of the interaction with the system and the system itself. So using the data or the metrics or of that interaction with the system, it has very little to do with the performance. Very little to do with the performance. So one of the things we are always saying is, please don't use it to measure the performance of the team, and especially don't use it to compare their performance, because they are interacting with the system in different ways, different areas of the system, with different context. Comparing, it's even worse. You destroy the culture. We've seen it. We can say that we've witnessed that. And, the automotive companies, any company, they work so hard to create a culture. I mean, they can be more or less successful, but they work hard in making sure that the people stay, that the people are fairly happy. And it's very sad to see part of that work, sometimes most of that work, destroyed because some people don't understand what they are measuring or doing. Okay, it's taking too long. Sorry about that. Let me go really quickly. 5 takeaways. The first one is, the first takeaway that I want to mention is, it works. This approach works for open source projects. We've seen it, and it works for commercial environments. And it works for automotive too. It does. A lot of what we've learned in one side, we can apply it into the other one. And also the other way around. We have learned stuff in working with in automotive companies that we have translated into open source. So it works both ways. Then if your company have a data strategy, try to push this kind of analysis into that data strategy. For example, I remember, seeing a fairly mature data strategy for data logging coming from the car, but they didn't consider this one as one of the potential areas of that data strategy. So it's good to do it. It will bring a lot of good knowledge and prevent a lot of mistakes. Keep focus on the key goals. I think we've mentioned this a couple of times already, so I'm not gonna insist. It's so easy to be pulled off in many other directions. Then I think you've heard it like 4 or 5 times already. Simplicity and end-to-end. Do not forget those 2 concepts. they are essential. If something is complex, think twice before doing it. And then do not start the house by a roof. Understand the behavior of your software production system before you start, or at least in parallel as you start applying machine learning. We've seen us coming after some AI company comes and do a lot of stuff, and then the results takes a lot of effort to make it meaningful, so much effort, and then the impact of those results are not very big. So, yeah. And that's about it. I don't know if there's going to be any question or...
Thank you so much, Luis and Agustín, for that excellent presentation. We really appreciate having you both here today. Let's see if anyone in the audience has any questions, please feel free to ask them now. This is the moment. Let's see.
If not, we can show some examples. Maybe that's also interesting.
Okay, yeah. If you would like to show some examples, that would be great. Yeah, as you prefer. The time is yours.
No. If we have, okay. So I'll show some examples. Maybe we can go directly to example number 3 and 4. Maybe those are the trickiest ones. Use case 3 and 4, Luis.
Slide number?
That's a good question. 42, I think it is.
3?
Yep, that one. Yeah, so talking about diagnostic, the kind of things that we do, that we've learned in open source and we do in commercial environments, and it works really well. If you move into the next one. So one of the things that reduce the performance of your software production system dramatically is variability. Variability is tough because if you are dealing with physical goods or with water or fluids, you see it. You see some effects, but not in digital. What tools do you prefer to support your BI strategy? What tools do you prefer to support your BI strategy? What tools do you prefer? I don't understand very well. Are you asking which tools we are extracting, we use as data sources, or which tool do we use? Okay, we use, let's see if I can answer that one. We use basically Grimoire Lab. It has the combination of the extracting the data, processing it, creating the data hub, and then have simple visualizations. Grimoire Lab already supports a whole bunch of data sources of tools we can extract the information from. But when we go to automotive, there is always one or two that the tool do not support, and we have to create some small modules in order to be able to extract the data on real time on our very regular cases and do the pre-processing without human intervention. I hope I answered the question. Okay, back to the variability part. Imagine that you are an OEM, for example, or a tier 1, and you are collaborating with different companies, and these companies give you code. I imagine you might have an inner source project to manage the software production. You might not. Different companies have different culture when it comes to software development. And you see that by analyzing the input, how the code lands into your system from them. And the variability, what happens with the variability is that when you apply pressure into your system, like for instance, imagine you get closer to a deadline, you apply pressure, and the variability, what happens is that saturate your system and then create bottlenecks where you didn't have them when you didn't apply pressure. And that's very common that's a common effect of the variability. You apply pressure, you see bottlenecks per saturation. One of the things we do is we analyze how the code comes in. For example, we try to analyze sources of variability. Batch size could be one. frequency, it's another aspect that might introduce variability, right? Because you don't have cadence. And then we look at the different organizations that are bringing code, and you can, by analyzing batch size, like average lines of code, number of commits, lines added, lines subtracted, or time interval, the concept of frequency or time interval, which is, for instance, what is the tag time for that code to come in. You see different organizations bringing you code at completely different cadences. And then at some point, the deadline approaches, and then you have a lot of code that you cannot deal with, and your integrators go nuts, or your testers go absolutely nuts, because suddenly they cannot handle the workload. So they become a bottleneck, and then the spotlight is on them, when in fact the problem is that these different organizations have a different understanding of how they have to work. And sometimes you have to go, in order to provide the remedies, sometimes it's not enough with telling them or them realize, sometimes you even have to go to the contracts. So you might not have, or increasing the capacity is the first measure. Oh, we increase the capacity when it comes to deadline, we put another person or two more people, and they will work extra hours or whatever. And you are not solving the problem. So the root cause is how they work, and the root cause might be the contracts for it. This is an example that I have experience with. So this is one of the examples. And if we go to the following one, for example, another aspect is dependencies. So yeah, this is another one of those cases that we've gone through more than once. When we analyze rework has a huge impact in a lot of places. But one of the main ones is well-being. Developers tend to not like to work in places where they have to be doing rework all the time, or rework suddenly increases in times, in periods in which it shouldn't. When the deadline is approaching, suddenly you have to do a lot of rework. It makes no sense. It's a symptom. So here, for example, we were analyzing rework, and so we were dealing with bug reports and the link between different organizations. This graph in the upper left-hand corner comes from an open source project where we are dealing with organizations and the relation with bug reports. And because they link the bug reports with the merge requests, in this case, I think it was, you can actually understand which areas of the code base are being reworked by which organization. So you get a picture there. And then you dig down, and you start to, okay, let's relate that area, these areas of the code with these teams. The ones on the right are from commercial environments. The one on the lower right-hand corner, you see there that from organizations you move to teams, and you try to figure out why is that rework happening? What is the source of the rework? And there are signals that might tell you, okay, dependencies might be going on here. So an easy way to spot that dependencies might be an issue is when you start to relate the activity of the teams related with the repos. And this is a particular case in which it was a constant source of rework, and the fixes, especially when they were critical or urgent, never came on time. And it was not because the teams didn't know what they were doing or were not putting enough effort. Dependencies were hitting hard. So we went down to, okay, can we drill down a little bit more? Let's see where the issue really is. And we ended up finding that it was just a matter of a limited number of files that were the cause of that dependency. So from there, you can jump into which strategies can we use to solve the problem. So, from the architecture perspective, or can we solve it from the code management perspective, or from the organization chart perspective? I mean, can we split the teams in a way that all these dependencies stay in one specific team? And if you cannot do those kind of things, so if you cannot break the dependencies, then you have to manage them. Okay, which management strategies can we apply so these things can work effectively? So these are the kind of potential remedies or potential that then you go to continuous improvement katas and you define experiments to see if they work. And if they work, you try to extend them, deploy them across the entire production system. So those are two examples of the kind of things we do in the diagnostic phase. Okay. Feeding product performance data into BI dashboards is familiar with tools like Grafana or Prometheus. Yeah, so of course we are. So most places that we go, they have Prometheus and Grafana. I mentioned one example. I mentioned before identities. So this is something that 99% of the cases we've gone to, they don't have solved it because Prometheus don't solve it. Prometheus is great for creating data lakes. Now for creating what we call data hubs, not so good. It's like many open source tools, right? Think about the one we use as an all-in-one. So it works very well if the scale is not too big. As soon as the scale is big, all-in-ones suffer. So you better separate them. For example, if you want to go deep into visualizations with our tool, it's not very good. So we have to use external tools, okay? Other kind of tools. The same happened with other areas. Think about, I don't know, GitLab, right? It's an all-in-one, and as long as you don't have a really big needs in one area, it works. With Prometheus and Grafana, we have the same kind of feeling, right? They are very good up to some point, but to start, I think they are completely overkill, and they lack all the features that you need in order to go really fast. So we have had several cases in which a lot of raw data is in Prometheus, so we don't have to go directly to the sources. We take it from Prometheus, we process it, we created it at a hub, and then we feed Prometheus again. And then they start work on visualization. So we create all the simple visualizations from the metrics that we have. And in parallel, we are helping the teams to bring those metrics into Prometheus and Grafana, and creating Grafana those visualizations that we use. We use our tool as a bypass as long as we need it. But the end goal is always that the customer is completely independent, right? It's that zero vendor locking. Sometimes they keep the tool, the Bitergia Analytics, in order to use it as a data hub. So they focus on serving the customers. And sometimes the goal is to shut down Bitergia Analytics and have everything in Grafana. We teach them everything. So at the end of the day, what we want is to move on into the next problem, not stay doing the same thing over and over. Sorting hat. Yeah. Sorting hat is one of the tools. Yeah. All right. I think we passed the hour. So.
Thank you so much. Okay, so we have some questions in the chat also happening. Thank you so much for showing more examples and answering all the questions. We really appreciate all your time and sharing your expertise with all of us today. Okay, so before we wrap up, we have a survey that helped us improve all our webinars, in this case, shifting gears with SDV. So we appreciate you guys to complete it. I just put the link in the call to action. And yeah, I think we don't have any more questions. Let me check as a question tab. No. All right. So I think there are no more questions, and I would like to thank you again, both of you, Agustín and Luis. And thank you everyone for joining us today. And we hope to see you again at a future webinar. Okay? Have a wonderful day. Bye-bye.
Bye-bye. Thank you.